Hey everyone, welcome back to Prep Academy. This is Mimi Hannah James. So we have already started our board exam preparations. So today in this video, we will be revising the chapter Vector Algebra. We will discuss the formulas, what is a dot product, cross product and its properties, and some important previous year questions. So shall we start? Okay. So what is a vector? That is, there are two types of quantities, scalar quantity and vector quantity. Scalar quantities are those quantities which have only magnitude, such as weight of an object. If I have an object, if it is 10 kg, it doesn't matter if I lift it upwards or downwards or towards the right. The direction has no role in that. It has only magnitude. Okay, 10 kg means 10 kg. But vector quantity are those quantities which has both magnitude and direction. That is 10 kilometers to the right and 10 kilometers to the left means different things. So we will reach at different destinations. So scalar quantities and vector quantities. So in this chapter we will be dealing with vector quantities. So thus quantities which has both magnitude and direction. Okay, so those quantities which has both magnitude and direction, such quantities are called vector quantities. So we have a, this is a three-dimensional space. So we have a point, okay, A. So how do we represent this point in a vector? That is, if this is xyz, the coordinate of this point is xyz, the position vector of xyz, the position vector of xyz means if we connect this point to the origin, we got this line. So the equation of this line is called the position vector. Okay, so a vector is equal to x I plus yj plus zk. How do we get that? Because here it is xyz and in the center it is 0, 0, 0. So x minus 0 I plus y minus 0 j plus z minus 0 k. That's how we got the position vector of A as xi plus yj plus zk. So for any point in the space, we can have a position vector that can be represented this way. Okay, now what is the magnitude? How do we find the magnitude of a vector? We find this, it's represented as modulus of a vector root of x squared plus y squared plus z squared. So if we have a point which is 1, 1, 1 in the space, so what is the magnitude? We represent the vector as I plus j plus k, since all of the coefficients are 1, and modulus of a vector here is root of 1 squared plus 1 squared plus 1 squared, right? So it is 1 plus 1 plus 1, 3. Root 3 is the magnitude of that vector. Okay, now depending on the magnitude, we can divide vectors into different types: unit vector, equal vectors, etc. So unit vector, as the name says, unit vector has the magnitude 1. Okay, so any vector which has a magnitude 1 is called a unit vector. For example, if we have a vector 1 by root 3, b vector is equal to 1 by root 3i plus 1 by root 3j plus 1 by root 3k. Okay, this is a vector. I am taking the magnitude of this vector. Modulus of b vector. How do we find a modulus? Root of x square plus y square plus z square. So here it is root of x square is 1 by root 3. So 1 by root 3 the whole squared plus 1 by root 3 the whole squared plus 1 by root 3 the whole squared is equal to root of 1 by root 3 the whole square is 1 by 3. So 1 by 3 plus 1 by 3 plus 1 by 3. That is 1 plus 1 plus 1, that is 3. Okay, 1 plus 1 by 3, that is root of 3 by 3, that is root 1, which is equal to 1. So we got the magnitude of this b vector as 1. So any vector which has the magnitude is equal to 1 is a unit vector, and if in some case we get the magnitude of 0, that magnitude is the vector is a 0 vector. Then when do we say that equal vectors, two vectors are equal? only if they have the same direction and the same magnitude. That is, all of their I components and j components and k components, they all should be equal. Only if they are equal, we'll say that okay, both of these vectors are the same. Then parallel vectors. So parallel vectors, when we say, if we can express a vector A and another vector B, if we can express in this way, A is equal to lambda B, then we can say that they are parallel vectors. And collinear vectors, collinear, from the name itself we can understand that collinear means co-line, that is they exist in the same line. Okay, they lie along the same line. They such, this is A vector and this is B vector. So such vectors are called collinear vectors. Coplanar means they lie in the same plane. Okay, in the same plane, the same xy plane or yz plane, they lie in the same plane. Okay, that's it. Now, unit vector. We know what is a unit vector. It is a vector with a magnitude 1. So for any vector, given vector, example here, a vector 1 1 1 itself, let's take it. So what is the unit vector corresponding to that vector? We have a vector is equal to I plus j plus k. So the unit vector corresponding to a vector can be found using this equation. A unit vector is equal to a vector by modulus of a vector. That is, here we got root 3 as the modulus, right? So if I divide this, the a vector is I plus j plus k. I am dividing it by modulus of a, that is root 3. Okay, so splitting it to everyone, that is I by root 3 plus j by root 3 plus k by root 3, that is a unit vector. We have already proved it in the case of B, it is a unit vector. So that is how we find a unit vector. How? Using this equation. This you have to learn. A vector by modulus of A vector gives the unit vector along A. Okay, it can be asked like unit vector along A or in parallel to A, in the direction of A, all means the same thing. Okay, now let's move on to the vector operations. That is, two vectors are there. How do we add them, subtract them, or multiply these operations? Okay, so okay, A vector is equal to I plus j plus k is a vector, and B vector is equal to 2i plus 3j minus 4k. Okay, so these are the two vectors. So addition, A vector plus B vector, we add it just by adding the I components with them and J components and K components. Okay, the corresponding components only. So here in the first vector, the I component is 1. In the second vector, the I component is 2. So 1 plus 2 is equal to 3. So A plus B vector has I component as 3i. Then J component, here it is 1 and here it is also 1. So 1 plus 1 is equal to 2. So plus 2j. Now here k component is 1 and j component is minus 4. So 1 plus minus 4 is 1 minus 4. That is minus 3. So minus 3k it is. That's how we just by doing the operation to the I components, j components and k components. Then A vector minus B vector, how do we do that? It is I minus 2. Okay, subtracting the corresponding I components. 1 minus 2, it is minus 1i. 1 minus 1, it is 0j. K minus, that is 1 minus minus 4. 1 minus minus 4, it is 1 plus 4, that is 5. So plus 5k it is. So this is how we do the addition and subtraction of two vectors. And scalar multiplication means I want to find 3 into a vector. That is, I want to multiply 3 to this a vector. That means I have to multiply 3 to all I, j and k, all the components. Okay. So 3i plus 3j plus 3k gives the 3a vector. Okay. Now we have this law, triangle law and parallelogram law of addition. Okay. So that is, we have, see, triangle law means this is a triangle And if A vector and B vector is two sides of a triangle, if A vector and B vector represents two sides of a triangle, then we can find the third side of the triangle just by adding them. Okay, A vector plus B vector gives the third side. Similarly, in a parallelogram, if we have two adjacent sides, A vector and B vector, then the diagonal can be found using A plus B vector. That's what we mean by triangle law and parallelogram law of addition. Okay, so in here we have to note the direction. A vector means AB. Okay, B vector means BC. So if we consider it as a route to reach to from A to C, we can reach from A to C in two ways. Okay, we can take the vehicle from A and reach B and then start there and reach to C. Okay, first A to B, then B to C. That is a way. Or another way is A to C. So in both of these methods, we can do it. So A to B and then B to C. That is AB plus BC is the same as AC. Okay. And in the case of a parallelogram, if we want to reach AC, we can go from A to B plus B to C, right? AB plus BC gives AC vector. So since this is a parallelogram, we know that opposite sides of a parallelogram are equal. So BC is same as AD, right? So AB plus AD is equal to AC vector. That's how we arrived at this conclusion that we can find the diagonal and and the other side of the triangle. Okay, so that's the triangle law and parallelogram law of vector addition. And then we had this section formula for finding the point. That is, if we have two vectors, A vector and B vector, and this is a vector joining. So in the line joining A vector and B vector, we have another point, okay, say R vector. So this R vector cuts the line in m is to n ratio. Okay, in this ratio, it cuts the line. So there we are asked to find the coordinate or the position vector. Okay, the position vector of R vector such that this line A and B is cut in the ratio m is to n, then we use this ratio. So if it is internal section or external section, we have two equations. Internal section means this one, that is the line joining AB is cut somewhere in the line, and external section means this is the line joining AB, and when this line is extended somewhere, it cuts on the line. Here in the outside is the R vector line. So if it's cut externally, we use the second equation, and if it's cut internally, we use this first equation. Okay. And then moving on to the dot product, we have two types of products. So the scalar multiplication was a multiplication of a scalar and a vector. So between two vectors, we have two types of products: scalar product, that is the dot product, and vector product, or it's called the cross product. Dot product and the cross product, two types of products are there. So the first one is dot product. A dot B is equal to mod A mod B cos theta. This is the equation. This you have to learn. Okay, A dot B is equal to mod B cos theta, and A cross B, if we learn it like comparing, it will be much easier. So for A cross B, it is mod A mod B sin theta n unit vector, because the answer of a dot product, when we do the answer, two vectors are producted, like it's a scalar product, the answer is a scalar. Okay, the value we get is a scalar. And for a vector product, the answer we getting will be a vector. Okay, so that we will do. That is, if we have two vectors, A is equal to I plus j plus k, and B vector we have 2i plus j plus 3k. Okay, These are the two vectors. I want to find the A dot B. So there are two ways actually. You can apply the definition. The definition is mod A mod B cos theta. If we know the theta or the angle between these two, we can directly use this. We can find mod A, then find mod B, and then find cos theta, then multiply it all. We get the answer. Or another way is we have to multiply the I components, then J components, and then K components correspondingly. Okay, that is here the I component is 1, here the I component is 2. So 1 into 2 is 2. No need to write I because the answer is a scalar. Okay, so 1 into 2, 2 plus 1 into 1, 1, 1 plus 1 into 2, sorry, this is 3. So 1 into 3, it is 3. So 3 plus 1, 4 plus 2, 6. So A dot B, the answer is 6. So when we applied dot product to two vectors, we got the answer as a number. Okay. But now in the case of a vector product, these are the two. This is how we find the vector using determinant method. Okay, we can use it using this method or the determinant method. So here also, if we have if we want to find A cross B, if we have the theta between them, we can find the vector product mod A mod B sine theta into n unit vector. It's a vector. Okay, that's a one method. Or the working rule is A cross B is equal to ijk, A1, A2, A3, B1, B2, B3. That is just by using the determinant method. Okay, let's do this example. That is A vector is equal to I plus j plus k, and B vector is equal to 2i plus j plus 3k. That's what we did earlier. So we are crossing them, A cross B. Okay, that is I, j, k in the top row. In the second row, we write the A. Okay, we write A vector. So that is 1, 1, 1, the I, j and k components of A vector. Now for the third row, we write the I, j and k components of the second vector, that is 2, 1 and 3. So 2, 1, 3. Now finding the determinant along the first row. Okay, so I into, okay, 1 into 3, 3 minus 1 into 1, 1. So 3 minus 1, 2. Minus j into 1 into 3, 3 minus 2 into 1, 2. So 3 minus 2 is 1. Plus k into 1 into 1, 1 minus 1 into 2, 2. So 1 minus 2, it is minus 1. Okay. So the final answer is 2i minus j minus k. So the cross product is a vector. That's why we call it a vector product and a scalar product. So the cross product is a vector. Okay. Okay. And the two conditions. Okay. So if a dot b is equal to 0, it means that a and b vector are perpendicular to each other. Okay, this is a condition that you will be able to use in many equations. So if we want to prove if two given vectors are perpendicular, if they are perpendicular to each other, just find a dot b and make sure it is 0. If it is 0, then they are perpendicular. Okay, and for the case of cross product, if A cross B is equal to 0, that means if A dot B is 0, it meant they are perpendicular. If A cross B is 0, we mean that A and B are parallel. Okay, they are two parallel lines. Okay, clear? And there are this components, the dot product and the cross product between the components, that is I dot I, j dot j, k dot k. They what is the answer for that? So I dot I is 1, I dot j is 1, and k dot k is 1. Any other product than this, that is I dot j or I dot k or k dot I, all of them are equal to 0. So I dot I equal to 1, j dot j equal to 1, k dot k equal to 1, all others are 0. When it comes to cross product, I cross I is equal to 0, j cross j equal to 0, and k cross k is equal to 0. Okay, if we cross product them to each other, the answer will be 0, but I cross j is equal to k. Okay, that is, if I and j is cross producted, then we get the answer k. Then j cross k is I, that is the next thing, j k, and the next thing is I. Then k cross I, ki, and the next thing is j. Okay, so this is how we did. And if we reverse the order, I cross j is k, that doesn't mean j cross I is k, the order is reversed. Okay, j cross I is equal to minus k. Okay, k cross j is equal to minus I, and k I cross k is equal to minus j. Okay, so if this is how it is, then kij is there, and if the order is reversed, minus 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 will be added. Okay, so also one more thing for dot product and cross product, this dot product is commutative. That is, if we find a dot b and b dot a, they are the same. A dot b, if we want to find the dot product, we can find either a dot b or b dot a, both will be the same. But in the case of vector product, it is totally different. Here is only we can see I dot j is k and j dot I is minus k, both are different, they are not at all equal. So in general, we can write a cross b is not equal to b cross a. It's not commutative. Vector product is not commutative. Okay, and then we want to find the projection vector. Okay, before that, we had these properties also for some algebraic identities for dot product. This you will have to know, and there will be definitely questions using using these identities. That is, they are just the same normal identities, normal algebraic identities, but it's in a dot product. Okay, the modulus is used. So normally we write a plus b the whole square is equal to a squared plus 2ab plus b square. Here we write the, here if normal multiplication, here it is dot product, that's all. So modulus of a plus b the whole square, a vector plus b vector, the modulus of them the whole square is equal to modulus of a squared plus 2 into a dot b plus modulus of b squared. Okay, so here a dot b is what? Mod a mod b cos theta, right? So that's how we do it. Mod a squared plus 2 into mod a mod b cos theta plus mod b squared. So that's the equation for mod a plus b the whole square. So all of these four, they are both, they all of them are the basic multiplication identities. So a plus b the whole square, a minus b the whole square, a plus b into a minus b equal to a square minus b square, and a plus b plus c the whole square. So all of these four equations you have to know. We will be doing problems based on all of this. Okay, and projection. Projection of a vector. Projection of a vector, with that we can find projection p vector using this equation, that is uh, projection of a on b. A on b and b on a is not the same. Okay, a on b and b on a is not the same. A dot b, a on b means this b comes on the denominator. On the numerator it is a dot b in both case. In the denominator it comes b, and on a means denominator comes in the a vector. Okay, the modulus of a vector. So projection of a on b, we find it using a dot b by mod b, and projection of b on a, it is a dot b by mod a. Okay, and using this vector products, we can find the area of triangle and area of parallelogram. Okay, area of triangle and area of parallelogram can be found. So area of triangle, if we want to find the area of triangle, if two sides of the triangle is a and b, okay, two sides of the triangle is given a vector and b vector, then we find it using this half into modulus of a cross b. We have to find a cross b first, then take the modulus, and then multiply 1 by 2 to it. Then area of parallelogram, if A and B are two adjacent sides, okay, A and B are two adjacent sides of a parallelogram, Okay, if it is like this, of a parallelogram A and B is given, then the area can be found using this equation, determinant of, modulus of A cross B. Okay, area of parallelogram, if diagonals are given. Okay, in some cases we get the diagonals. If two adjacent sides are given, you can use this equation. Two diagonals d1 vector and d2 vector, if they are given, we find it using 1 by 2 modulus of d1 cross d2. Okay, 1 by 2 modulus of d1 cross d2. That also you have to learn as one of the formulas. Okay, so that's it. That's what we had to do about all of these topics. Now we will do some of the problems, some MCQs and everything, and you will be clear about it. Okay, so this is the first question. It's an MCQ question. Find the distance of the point P of ABC from the y-axis. So let's, this is a coordinate, and P of ABC is a point. Now we want to find the distance of this point from y-axis. Okay, if this is y-axis, the distance is this, right? Like the perpendicular distance. So it can be drawn like this, but that's not the distance. This perpendicular line, the length of the perpendicular line drawn is the distance. This is the distance. So using distance formula itself we can use. So that is root of a squared. Distance formula is x2 minus x1 the whole squared plus y2 minus y1 the whole squared plus z2 minus z1 the whole squared, right? So this is root of a minus, what is the x coordinate here? So in y axis the x coordinate and z coordinate are 0, right? For y axis x equal to 0 and z equal to 0. If in z axis x and y is equal to 0, in x axis y and z is equal to 0. So here we have y axis, so x and z is 0. So a minus 0 the whole squared plus b minus, here what is the coordinate? If this is b, this is also must be b. So b minus b the whole squared plus c minus 0 the whole squared. So that is equal to root of a squared plus 0 plus c squared. So a squared plus c squared, yeah, option 4, a squared plus c squared is the answer. Okay, that's how we do that. Now let a vector be any vector such that modulus of a vector is equal to a, the value of this. We want to find the value. Okay, so first we will find the value of modulus of a cross I. So what is modulus of a cross I? Just by using the definition, modulus of a cross I is mod a mod I sine theta, right? Just by using the definition. Now what is mod a? It is a, right? It is given in the question that mod a is a and modulus of I is a unit vector, correct? I, j and k are a unit vector. So the magnitude of I is 1. So a into 1 into sine theta. What is theta? Theta is the angle between a and I. So if it is a cross b, we mean theta is the angle between a and b. So here it is a cross I. That is angle between a and I. What does this I mean? I actually represent the x axis, right? So angle between a and x axis, it is alpha, right? So angle between, if this is the plane, the angle between the line and x axis is alpha, angle between the line and y axis is beta, angle between the point, the line and the z axis is gamma. So here sine alpha it is. Okay, now we'll take the next one, a cross j. A cross j is equal to, similarly, mod a mod j sine theta. Mod a is a, j is 1 into sine alpha is changed. Here it is beta. Okay. Then a cross k is equal to mod a mod k sine theta, that is a into sine gamma. Okay, now we will substitute in this equation. We want to find mod a cross I the whole squared plus mod a cross j the whole squared plus mod a cross k the whole squared equal to. So mod a cross I is a sin alpha. So the whole squared is a sin alpha the whole square. So a square sin square alpha, correct? Plus a squared sin squared beta plus a squared sin square gamma. Now that is equal to, we can take a square common outside. So a square into sin square alpha plus sin square beta plus sin square gamma. We are not there yet. We have to simplify this. So what can we do about sine square? We know that sine square alpha is 1 minus cos square alpha, correct? Sine square x is 1 minus cos square x. So 1 minus cos square alpha plus sine square beta is 1 minus cos square beta plus sine square gamma is 1 minus cos square gamma. Okay, now this is 1 plus 1 plus 1. It is 3. Taking minus outside, what do we have? It is cos square alpha minus we took outside, so it is plus cos square beta plus cos square gamma. Now what is cos square alpha plus cos square beta plus cos square gamma? They are the direction cosines, isn't it? Direction cosines that we have discussed in the three-dimensional geometry chapter. Here also it is important. It is connected. The vector and three-dimensional geometry is connected. So for direction cosines, that is cos square alpha plus sin cos square beta plus cos square gamma is 1. Okay, cos square alpha plus cos square beta plus cos square gamma is equal to 1. That is what a direction cosine means. So a square into 3 minus 1 is equal to 2a square. Okay. So let's see if that's in the equation. Yeah, option 2, 2a square. So 2a square is the answer. Okay. Moving on to the next question. Let a vector and b vector be two unit vectors and theta is the angle between them. Then a vector plus b vector is a unit vector if theta is. Okay, so we have two vectors, a vector and b vector. It is given that they are unit vectors. That is, modulus of a vector is equal to 1 and modulus of b vector is also equal to 1. And also it is given that theta is angle between a and b. Now we want to find the angle between a plus b, right? Then a plus b is a unit vector. So it is also given that a plus b is a unit vector. So we are taking that a vector plus b vector is a unit vector. The modulus of a plus b vector is equal to 1. Now we want to find what is theta there. So for such questions, we do squaring. Okay, this is what we have. We have modulus of a plus b is equal to 1, squaring both sides. Okay, squaring both sides. Almost in all these types of questions, the first step we do is squaring. So if we do squaring, we can have some formulas from those algebraic identities, right? Okay, so a plus b the whole square is equal to 1 square. 1 square is 1 itself. Now let's see what is a plus b the whole square. From the first formula, it is mod a square plus mod b square plus 2 a dot b. Correct? So mod a squared plus mod b squared plus 2 a dot b. A dot b is mod b cos theta. So I am writing that mod a into mod b into cos theta equal to 1. Now we know what is mod a. Mod a is 1. So 1 squared plus mod b is 1. 1 squared plus 2 into 1 into 1 cos theta is equal to 1. So 1 plus 1 is 2. 2 plus 2 cos theta is equal to 1. I'm taking 2 outside, so I have not 2 outside. I want to isolate theta, right? So moving this 2 to the right side, I get 2 cos theta is equal to 1 minus 2. It is 1 minus 2, it is minus 1, and cos theta is equal to minus 1 by 2. So what is theta? Theta is equal to cos inverse of minus 1 by 2. So cos inverse of 1 by 2, it is 60, that is pi by 3, correct? Cos inverse of pi by 2, cos inverse of 1 by 2, cos inverse of 1 by 2 is pi by 3. So cos inverse of minus 1 by 2, it is pi minus pi by 3. Okay, that is 3 pi minus pi, 2 pi. 2 pi by 3. So our answer, the theta is 2 pi by 3. This we did using the trigonometric formulas in that we have learned in class 11 and also in 12th also. Okay, so this is it. So let's see, yeah, option 4, 2 pi by 3 is the answer. Okay, is it clear? So the first thing we did is squaring on both sides. Then using the identities, we solve the answer. Now, if mod A is equal to 8 and mod B is equal to 3, mod of A cross B is equal to 12. So all these values are given. We want to find A dot B. Okay, so we have this mod of A cross B is equal to 12. So from that, what is the equation of mod of A cross B? It is mod A mod B sine theta, correct, is equal to 12. So we know mod A. What is mod A? It is 8 into mod B is 3. 8 into 3 sine theta is equal to 12. That is 24 sine theta is equal to 12. Sine theta is equal to 12 by 24. That is 1 by 2. Okay. Then theta is equal to sine inverse of 1 by 2. Sine inverse of 1 by 2 is 30 degree, that is pi by 6. Okay, so we got theta as pi by 6. What we wanted to find? We wanted to find A dot B. So A dot B is, by definition, A dot B is mod A mod B cos theta. So we have mod A, mod B and theta. We have obtained it now. So now we can solve it. So mod A is 8 and mod B is 3 and cos theta, that is cos pi by 6. Okay, so 8 into 3, that is 24 into cos pi by 6, it is root 3 by 2. Okay, so the answer, it is 2 and 24 will get cancelled, so 12 root 3. 12 root 3, yes, option 3, 12 root 3 is the correct answer. Okay, we wanted theta in order to complete the answer for A dot B. So we found A dot theta using the given informations. Okay. The next question, if mod A cross B is equal to root 3, it is given. A dot B is equal to minus 3, that's also given. Now we want to find the angle between theta. Angle theta between A and B vectors. So we can write it as we know, A cross B is equal to root 3. Definition, from definition, A cross B is mod A mod B sine theta. Okay, that is equal to root 3. That is equation number 1. And A dot B is equal to minus 3. So from that also, from the definition, mod A into mod B cos theta is equal to minus 3. That is equation number 2. Okay, I am dividing equations 1 and 2. Okay, 1 divided by 2, that is mod A mod B sin theta by mod A mod B cos theta. That gives us root 3 by minus 3. So cancelling it, I'll get root 3 and 3 will get cancelled. In the denominator we have minus root 3. So minus 1 by root 3. Okay, what is minus 1 by root 3? So A and A get cancelled and B get cancelled. So sin theta by cos theta. Okay, that is tan theta is equal to minus 1 by root 3. So from that we wanted to find theta. So theta is equal to tan inverse of minus 1 by root 3. So tan inverse of 1 by root 3 is pi by 6. Sorry, pi by 6. Tan inverse of 1 by root 3 is 30 degree, that is pi by 6. So it is minus 1 by root 3, that is pi minus pi by 6, which is 6 pi minus pi, 5 pi. 5 pi by 6. 5 pi by 6 is the correct answer. Okay. So we have to know this, like minus, that's also from the formulas of class 11 and 12. We got it, pi minus pi by 6 is the answer, that is 5 pi by 6. Next, for what value of lambda is the projection of the vector a vector is equal to I plus lambda j on the vector b vector is equal to I minus j equal to root 2. So we have given two vectors, a vector and b vector, and it is given the projection value is root 2. Projection of this and this equal to root 2. It is given, the projection is given. We want to find the value of lambda. So projection of vector on B. So A on B, projection of A on B is given as root 2. So by definition, projection is A vector dot B vector by on B it is said. Okay, on B. So modulus of B vector is in the denominator. It is equal to root 2 is given. We can find A dot B and mod B. We have given both of them. So what is A dot B? A dot B is equal to, how do we find the dot product? I components multiplying, j components multiplying, and k components multiplying. So here I components are 1 and 1. So 1 into 1 is 1 plus j components lambda into minus 1, minus lambda. So 1 minus lambda, that is A dot B. Okay, so 1 minus lambda by mod B vector. Modulus of B vector, it is root of 1 squared plus 1 squared is equal to root 2. Okay, so root 2 is equal to root 2. Now I am moving this root 2 into the other side. We get 1 minus lambda is equal to 2, and then we have minus lambda is equal to 2 minus 1 minus 1, 2 minus 1 1, and lambda is equal to minus 1. So let's see, lambda is equal to, lambda is equal to minus 1 is there. That's the answer. Okay, we just applied right to the equation of projection. Okay. The value of j dot j cross k is, we want to find the value of j dot j cross k. So first we will do whatever it is in the bracket. J dot j cross k. From the definitions I've given, j cross k. See, j cross k is I. J and k, and then the next element is I. So j cross k is I. Now j dot I is 0 because only I dot I, j and k dot k are 1. All others are 0. So j dot I is 0. So now final answer is 0. Okay. Now given a vector plus b vector plus c vector is equal to 0, and a vector modulus is there, b vector modulus and c modulus is there. We want to find the angle between a and b. Okay, we want to find the angle between a and b. So we have this a vector plus b vector plus c vector is equal to 0. From that we can write that a plus b is equal to minus c vector, right? Okay. Now the next step is squaring. See, as I said, we've done in a previous question, if we some of these kind of question comes, square and then apply the identity. That is the only way. Okay. So squaring on both sides, we have modulus of a plus b the whole squared is equal to minus c the whole squared. So expanding, we have modulus of a squared plus modulus of b squared plus 2 mod a mod b cos theta. From those identities itself, it is 2a dot b I've just expanded what is A dot B. A mod B cos theta is equal to mod of minus c square is equal to mod of c square. Modulus of c and minus c, the direction is just changed. Magnitude remains the same. So mod of minus c square is the same as mod of c square. Now substituting the values. So if I substitute, I think I will get the angle theta, correct? Let's see. Okay, so a square, a is 3, 3 square is 9 plus b square, b is 5, so 25 plus 2 into mod a mod b, that is 3 into 5 cos theta is equal to mod c square, that is 49. Now changing all of these together, so we get 3 to the 6, 5 is 30. 30 cos theta is equal to 49 minus 9, it is 40. 40 minus 20, it is 20. 20 minus 5, it is 15. So 50. Okay, changing all of these to the right side. Now cos theta is equal to 15 by 30, that is 1 by 2. So theta is equal to cos inverse 1 by 2, which is pi by 3. Okay, pi by 3. So that is what we wanted to find. We wanted to find the angle between this. So we wanted to find angle between A and B. So A and B, see here 2 mod A mod B cos theta. That means theta is between A and B. If it was mod A mod C cos theta, it would have meant theta is the angle between A and C. So we wanted angle between A and B. That's why we arranged it accordingly. Okay. Okay, moving on. The magnitude of the vector product of the vector A vector with the unit vector along the sum of B and C is equal to root 2. Find the value of lambda. So for these type of questions, read carefully. Read very carefully. Just understand what we are asked to do first. We want to find the value of lambda. Where is lambda? Oh, it's here in the C vector. Lambda is right there. So the magnitude of the vector product of the vector with the unit vector along the sum of vectors B and C. So first we want to find the sum of vectors B and C. Okay, sum of vectors B and C. First we want to find the sum of vectors B plus C vector and then unit vector along the sum of B and C. That is, first we want to find B plus C, then we want to find the unit vector along B vector. So unit vector along A vector is A vector by modulus of A vector, correct? So unit vector along the sum is this divided by its modulus. Anything divided by its modulus is the unit vector. So, and then we found the unit vector and then vector product of A and this unit vector. So then we have to find the A cross this whole thing. Okay, that's what we want to find. Now we will start doing the. So first we want to find the B plus C. Let's do it. B plus C vector is equal to 2 plus lambda. 2 plus lambda I and j components and k components are multiplied and added correspondingly. 2 plus lambda I, 4 plus 2, that is 6, j minus 5 plus 3, that is 3 minus 5, it is minus 2 k. So that is B plus C vector. Now we want to find the magnitude of that. Modulus of B plus C vector is equal to root of 2 plus lambda squared plus 6 squared plus 2 squared. Right? X square plus y square plus z square. So root of 2 plus lambda square, I'm keeping it like that, plus, okay, or I'll solve it. So 2 plus lambda the whole square, it is 2 squared, that is 4 plus 2 into 2 into lambda, that is 4 lambda plus lambda squared plus 6 square, it is 36 plus 2 square it is 4. So the answer is finally lambda square plus 4 lambda plus 36 plus 4 40, 40 plus 4 44. So this is mod B plus C. So what is the unit vector along sum of vectors B and C is equal to sum of vector divided by its modulus. Okay, so that is sum of vectors was 2 plus lambda I plus 6j minus 2k by root of lambda square plus 4 lambda plus 44. Okay, now yeah, that's it. Keep it like that. Now we want to find the vector product of A with this unit vector. Okay, we have the unit vector. Now we want to find the vector product with this unit vector. That is A cross this vector. So A vector cross B plus C unit vector is equal to determinant method, that is I, J and K. The I component of A for A vector, the I, J, K components are 1, 1, 1. So 1, 1, 1. J components, it is here, this is the unit vector. So 2 plus lambda by root of lambda square plus 4 lambda plus 44. Here 6 by root of lambda square plus 4 lambda plus 44. Here it is minus 2. So minus 2 by root of lambda square plus 4 lambda plus 44. So this is what we want to find. So I into, just by opening, okay, I into 1 into minus 2. So minus 2 minus this cross multiplying, it is 6 by the denominators for both of them are same, that's why I am doing this. Root of lambda square plus 4 lambda plus 44, then minus j into minus 2 minus 2 plus lambda, correct? This is j, so 1 into this and 2 plus lambda into this, so that's it. So by root of lambda square plus 4 lambda plus 44 plus k into 6 minus 2 plus lambda by root of lambda square plus 4 lambda plus 44. Now solving, we get I, we have all the denominators all the same, so I'm just writing the numerators. So minus 2 minus 6 is minus 8. Taking this minus outside here, so we get plus j. So we have minus both here, minus 2 and minus 2. So took the j outside. So 2 plus lambda, that is 4 plus lambda, correct? So 4 plus lambda plus k into 6 minus 2, that is also 4 plus lambda. Okay. So divided by lambda square plus 4 lambda plus 44. Now we want to find the magnitude. Okay. A cross B we did it. So we want to find the magnitude of the vector product. Okay. So magnitude of A vector cross B plus C unit vector is equal to root of this whole term, correct? The I component here is minus 8 by root of this lambda square plus that the whole squared plus 4 plus lambda the whole squared by root of lambda square plus 4 lambda plus 44 plus 4 plus lambda by root of lambda square plus that whole square. Okay. Now this is equal to the denominator, the when it gets squared the root will go. So denominator it is lambda squared plus 4 lambda plus 44 for all the terms, and here it is, it is a 64 and opening it. It is plus 4 squared I'll be writing in the next page. So this is it. We are opening it. Root of 8 square, it is 64, plus 4 plus lambda the whole square. A plus b the whole square, that is a square 16 plus 4 to 0 8 lambda plus lambda squared, plus here it is also 4 plus lambda. Wait. Okay, sorry. Here we had, this was the term, right? So 6 minus 2, 4, and this minus also goes inside. So it was 6, 4 minus lambda. Okay, my mistake. Sorry. So it was 4 minus lambda the whole square. So it is 4 square is 4 square. It is 16 minus 8 lambda plus lambda square. Okay, and the denominator, when it gets squared, it is lambda squared plus 4 lambda plus 44. And that is equal to, on solving, this 8 lambda and 8 lambda will get cancelled. Lambda square and lambda square we get, it is 2 lambda square. Then 64 plus 74, then 80, 90, 96. Okay, it is 96 by lambda square plus 4 lambda plus 44. Okay, this is the root. Now in the question, it is given that the magnitude of this with the unit product and whatever it is, this is equal to root 2. Okay, the answer is given in the question. We want to find the value of lambda. So it is equal to root 2. So this is equal to root 2. So now I want to find the value of lambda. What do we do? Square. Correct? In order to remove this root, we will squaring on both sides, that is 2 lambda square plus 96 by lambda square plus 4 lambda plus 44 is equal to 2. Moving this to the other side, I get 2 lambda square plus 96 is equal to 2 into lambda square plus 2 into 4 lambda, it is 8 lambda plus 2 into 44, it is 88. Okay. Now this 2 lambda square and 2 lambda square get cancelled, and here we have 96 minus 88. So that is 8 is equal to 8 lambda. So lambda is equal to 8 by 8. So we get 1. So we got the value of lambda is equal to 1. Okay, that is what we wanted to find. So in this type of question, what do you want to do? You have to read the question very carefully. Okay, only if you read the question thoroughly, you'll get what do you want to do. So we had to find the sum first, and then the unit of the sum vector, unit vector of that vector, and then the vector product of A with that unit vector and magnitude of that vector. And also it is given that it is equal to root 2, we equate to the root 2 and then find the value of lambda. Okay, it's a very simple question. If you know the procedures and all, just you have to read it carefully. Okay, next question. Let A vector, B vector and C vector be three vectors such that mod A equal to 1, mod B equal to 2, mod C equal to 3. If the projection of B along A is equal to, okay, let's write whatever it is given. They are three vectors. Mod A vector is equal to 1, mod B vector is equal to 2, and mod C vector is equal to 3. The projection of B along A is equal to the projection of C along A. So projection of B along A means, the what is the equation for projection of B along A? It is A dot B. Okay, on the numerator it is A dot B by along A it is. So modulus of A square is in the denominator. Not A square, modulus of A. Okay. Is it A square? Let me check. Wait. Modulus B. That is the projection. Okay. So modulus of A is on the denominator, and it says that it is equal to projection of C along A. That is A dot C by modulus of A. So it is given that these both of these projections are equal. So just by the definition, I equated them. Okay. Now, and also given B and C are perpendicular to each other. So B and C are perpendicular to each other means, by the definition of the dot product I said, if two vectors are perpendicular, their dot product is equal to 0. So B dot C is also equal to 0. So all of these are the informations from the questions. Now we want to find the value of this. Okay, let's do it. So also from this, the denominators are same, right? A dot B by mod A is equal to A dot C by mod A. So if the denominators are same, then the numerators also must be the same. So from this we get A dot B is equal to A dot C. Okay, so and B dot C is equal to 0. All of this information we have. Now we are opening this modulus of 3A vector minus 2B vector plus 2C. So I'm just squaring, okay, finding the square of this equation, just as we have done in earlier questions also, squaring. So from these equations, what is the for three vectors, the square is modulus of a square plus b square plus c square plus 2 into a dot b dot c dot a. Let's do that. So modulus of 3a vector squared plus modulus of 2b vector squared plus modulus of 2c vector squared plus 2 into a dot b dot 3a, sorry, that's so 3a vector dot minus 2b vector. Okay, a dot b it is, yeah. Then plus 2 into b dot c, correct? 2b minus 2b vector dot 2c vector plus then a dot c, that is 3a vector dot 2 into c vector. Okay, now here it is a square, so modulus of 3a square means 3 square, 3 9 into modulus of a square, that is the square is applicable to both a and 3. Okay, so 9 into mod a square plus here also 4, 2 square is 4, so 4 into mod b square plus 2 square is equal to 4 into mod c square plus 2 into, here it is 3 into 2 minus 6 a dot b, correct, minus 6 a dot b. Here it is minus 4 a dot c, it is minus 2 into plus 2. Sorry, here it is minus 2 into plus 2, so it is b dot c, minus 2 into b dot c plus 3 to the 6, 6 into a dot c. Okay, now here we have b dot c is equal to 0. So this term will be equal to 0. And also we have a dot b is equal to a dot c. So a dot b is equal to a dot c means we can write that as minus 6 into a dot b plus 6 into a dot b. That is, they will also will be 0. So this whole term goes to 0. Okay, so what is remaining is only this. So 9 into modulus of a square is 1, the whole square. So 1 plus 4 into modulus of b square, it is 4. 4 into 4 plus 4 into modulus of c square, it is 3 3s are 9. Okay, so 9 plus 4 4s are 16 plus 9 4s are 36. That is 36, 45, then 55, 61. Okay, so the whole squared is 61. So we don't want the square, we want just the magnitude. So modulus of 3a vector minus 2b vector plus 2c vector is equal to root 61. Okay, so that is the answer. So here also we have did the square and just applied the formula. Okay, the dot product, the algebraic formulas. The next question. Find the area of the parallelogram ABCD whose side AB and diagonal AC are given by these two vectors. So we want to find the area. So we know the formulas for finding area, correct? By using two diagonals. If we have two diagonals of the parallelogram and if we have two sides of the parallelogram, we have two different formulas. But here it is given that one side and one diagonal is given. How do we find that? If we had two sides or two diagonals, we could have found using any of those equations. So let's see. So this is the parallelogram A, B, C, D. Correct. So side AB is given, that is AB, that is the direction is here. So AB is given as 3i plus 3i plus j plus 4k, and AC is given. This is the diagonal. AC is given as 4i plus 5k. So we want to find the BC vector, okay, or AD vector, anything. So, okay, yeah, we can find the AD vector. So if we have AD vector, then we will get two sides. Then you can use the area of parallelogram using sides formula. Okay. So AD vector. So using parallelogram law of addition, if we add two adjacent sides of a parallelogram, we get the diagonal. Correct. So where is it? Yeah, this is the parallelogram law. So if we add A plus B gives the diagonal. So here the two sides are AB vector plus AD vector gives AC vector. So from this we want to find AD vector. So AD vector is equal to AC vector minus AB vector. We just moved it to the right side. So find AD vector, AC minus AB. So AC is 4 and this is AB. So I component, so 4 minus 3 it is I. J component, here J component is 0, so there 0 minus 1 minus J. Here it is 5 minus 4, it is plus K. So that is AD vector. So now you can use the area of parallelogram formula. So area of parallelogram with two adjacent sides. Okay, two adjacent sides given is AB vector cross AD vector. Okay, they are direct cross product. So cross product is done using like this. IJK. Components of AB vector is 314. 314. And AD vector, components of AD vector is 405. 40 and 5. So using the determinant method, it is I is equal to 5 3s are 15. I into I into 5 minus 0. So 5i minus j into 15 minus 4, that is 11, plus k into 3 minus 0 minus 4, that is minus 4. Okay, so 5i minus, this is AB cross AD. So minus 11j minus 4k. So we want to find the modulus of AB cross AC. The modulus of AB cross AC is the area. So modulus of AB cross AC is equal to root of 5 squared plus 11 squared plus 4 squared, that is root of 5 squared is 25 plus 121 plus 16. Oh, sorry, my mistake. I did, we had to do AD vector, right? We found AD vector, but I accidentally wrote this diagonal AC itself here. It was IJK314 and it is 1 minus 1 and 1. Okay, 1 minus 1, 1. That was the correct answer. So I into 3 minus 4, which is I into 1 minus minus 4, that is 5, minus j into 3 minus 4, that is minus 1, plus k into minus 3 minus 1, that is minus 4. Okay, so that is 5i plus j minus 4k, and the modulus of AB vector cross AC vector is equal to root of 25 plus 1 plus 16. Okay, that gives us 26 plus 16 is equal to 42. Okay, so root 42 is the area. So don't make these kind of silly mistakes you because of carelessness like me. Okay, have to be careful. Okay, next question. The two vectors I plus j plus k and 3i plus j plus 3k. So we have two vectors. They represent the two sides OA and OB respectively of a triangle OAB where O is the origin. So we have this. Okay, this is the axis. This is O. O is the origin, and OAB is a triangle. Okay, OA is a side and OB is a side. Okay, this is OA vector and this is OB vector. So both of these are two sides of a triangle. The point P lies on AB such that OP is a median. Median means P cuts the line AB into same two equal sides. Okay, so that is it is the middle point. So P is the middle point of AB. We want to find the area of parallelogram formed by two adjacent sides OA and OPS vector. So we want to find the parallelogram OA, OP vector adjacent sides. Okay. So we have OA, so we don't have OP. We want to find this OP. So how do we find that? This is the midpoint. So if we have the coordinates of P vector, the position vector of P vector is the OP vector. So what is the how do we find the position or the coordinates of P? It is the middle point, right? Using section formula, if it's a median, the ratio is 1 is to 1. That is M is equal to N is equal to 1 in that section formula. So since P is the median of AB, we can write that OP vector is A vector, sorry, OA vector plus OB vector divided by 2. Okay, using the section formula, here we had the section formula. So here if M and N is equal to 1, B plus A plus B by 1 plus 1, 2. So A plus B by 2. So that is what we are applying here. So A plus OB by 2. So OA plus OB, that is 3 plus 1, 4i plus 1 plus minus 1, that is 0j plus k plus 3k, that is 4k by 2, that is equal to 2i plus 2k. So 2i plus 2k is the OP vector. Now we want to find the area. It is now simple using the area of parallelogram. Area of parallelogram is equal to modulus of OA vector cross OP vector. So OA vector cross OP vector is equal to ijk. OA vector it is 1 1 1 and OP vector it is 202. So that is equal to I into 2 minus 0. So that is 2 plus minus j into 2 minus 2, that is 0 plus k into 0 minus 2, that is minus 2. Okay, so it is 2i minus 2k. 2i minus 2k is the vector. So OA vector, the determinant of OA vector cross OP vector, that is area is equal to root of 2 square, that is 4 plus 2 square 4, that is root 8. We can simplify it as 2 root 2, correct? 8 on simplification, we get 2 root 2. Okay. So the area of the parallelogram formed in such a way is 2 root 2. Next question. In a parallelogram PQRS, PQ vector is equal to 3i minus 2j plus 3k. So we have two vectors PQ and PS. We want to find PR and QS. So here also we can draw a parallelogram just for making our things easy. PQR S is the parallelogram. So PQ vector is 3I. This is given. PQ vector, this direction PQ vector is given. Then PS vector is this PS. Okay, so PQ and PS is given. We want to find PR. Okay, so PR, that's what we want to find. PR vector we can find, correct, using parallelogram law. It is very easy to find PR vector. So this is the parallel. So since this is a parallelogram, so this PR, PQ and PS are two adjacent sides. Then PR is the diagonal. Using parallelogram law, the diagonal is the sum of these two adjacent sides. So using parallelogram law, we have PR vector is equal to PQ vector plus PS vector. So PQ is this, PS is this. So PQ 3 minus 1. So 2I minus 2, here it is 0. So minus 2J, 2 plus minus 2, that is 0K. Okay, so 2I minus 2J, it is the PR vector, and the modulus of PR vector is root of 2 to the 4 plus 4 is equal to root 8. Yeah, so it is 2 root 2. Now QS vector. QS vector means it's in this direction. Right, this is the direction for QS vector. So QS vector, this is not, this is the other diagonal. So if we want to find this, it is QS. If we want to reach QS, we have to go QR plus RS. Okay, but the thing is, we don't have QR and RS, right? We can say that since this a parallelograms, the sides are opposite sides are equal, so we can write PS is equal to QR, but PQ is actually equal to SR. We want RS, so the direction is reversed. Okay, so the direction is very important. That is QR plus RS will give QS, but we don't have RS. We only have SR. Okay, PQ, the same direction follows upwards also. That is SR. Okay, so here from this picture also we can write this is PQ is here and QS is here. So PQ and QS, see, PQ plus QS is equal to PS. Correct. From this image, I reached P to Q and then to Q to S or directly P to S. So PQ to QS is equal to PS. PQ plus QS is equal to PS. So from that, what is QS? It is PS minus PQ. So PS is minus 1 minus 2K and PQ is this. So we subtract it. That is minus 1 minus 3, it is minus 4I, 0 minus minus 2, it is plus 2J, 2 minus 2 minus minus 2. So it is minus 4K. So the modulus of QS vector is root of 4 square, that is 16 plus 2 square, that is 4 plus then 16, that is 26. 20 plus 16, so it is 36. So root of 36 is 6. So that's how we found. So we can actually find if we reverse the direction of SR. Okay, we have SR, PQ is equal to SR. So if we want RS, RS is equal to minus of SR. We can do it that way also. Okay, so both of them are correct. This is one method. Okay, what you have to be careful is about the direction. RS and SR is not the same. They are the negative of each other. Okay, that's it. So let's move on to the last question. The two adjacent sides of a parallelogram are represented by A vector is equal to 2i minus 4j minus 5k and B vector. So two adjacent sides of a parallelogram are given. We want to find the unit vectors parallel to its diagonal. So this is a homework for you guys to find out. So comment below the answers. Okay. So if any doubts arise during the workout, you can ask in the comments itself. So the two adjacent sides are given. We have A vector and B vector as two adjacent sides of the parallelogram. We want to find the unit vector parallel to diagonal. So if we have these two adjacent sides, then we can definitely find the unit vector d1. And the unit vector d2. Here also, this is equal to A vector and this is equal to B vector. There also we can find the unit vectors d1 and d2. So if we have d1 vector and d2 vector, how do we find the unit vector? Just by dividing it using the magnitude of them. So d1 unit vector is d vector divided by modulus of d1 vector. That also you can find. Okay, and then also using diagonals, find the area of parallelogram. So area of parallelogram using diagonals is 1 by 2 into modulus of d1 cross d2. So this is the formula you need to use. So try it out as a homework and comment the answer. So thank you for watching the video and all the best for your exams. We'll see you with another video. Till then, bye. Thank you.